Dear student, today we solve one more problem on GRR and NRR, that is growth rate. In our previous class also we solved one problem where we got both GRR and NRR more than 1. So when we get GRR and NRR both greater than 1, the conclusion is population is going to increase. And when we get both less than 1, either GRR or NRR both less than 1, the conclusion is less than 1 means population is going to decrease in future. But when we get GRR more than 1 and NRR less than 1, then what would be the comment? So here there is a problem where we get GRR more than 1 and NRR less than 1. Let us try this problem. So compute GRR and NRR and comment on the growth rate. And here age group 15 to 19 till 45 to 49, 5 age with the total 7 classes were given. That means I is equal to 5 here. And next female population in different age group and female laborers in those age groups were given, and also survival rate which we need to calculate NRR. Now let us calculate first WSFR, which is required for calculation of both GRR and NRR. So what is the formula to calculate WSFR? So WSFR formula is WSFR is equal to number of female live births to a specified age group in the year divided by total number of females in the particular age group in the year into 1000. So in short, if you write it, WSFR is equal to female births of age group X divided by female population of age group X into 1000. So let us calculate first one here, that is age group 15 to 19. WSFR 15 to 90 is equal to live female births are 480 divided by female population in that group is 16,000 into 1000. So we get 480 divided by 16,000 into 1000. So 3 zeros will get cancelled. 16 ones are and 16 30s are. We get 480. So answer is 30 here. Let us calculate remaining and write them in columns here. You need two columns, WSFR, which is required for computation of GRR, and next WSFR into survival ratio S. So first WSFR is 30. Let us calculate WSFRs first. Second WSFR for age group 20 to 24, live births of females are 812 and female population of that age group is 14,500. So 812 divided by 14,500 into 1000, we get 56. So second WSFR is 56, and next third one 650 divided by 13,000 into 1000, we get 50. Next 460 divided by 11,500 into 1000, we get 40. And fifth age group 300 live births divided by 10,000 into 1000, we get 30. And next 87 divided by 8,700 into 1000, we get 10. And last 30 divided by 7,500 into 1000 we get 4. Now WSFR into S. So survival ratio into WSFR column. So first one 30 into 0.91 we get 27.3. 56 into 0.9 50.4. 50 into 0.89 44.5. 40 into 0.8 35.2. 30 into 0.87 26.1. 10 into 0.86 8.6, and the last 4 into 0.85, that is 3.4. And now the totals of both the columns. WSFR column total 6 plus 4 10, carry 1 plus 1 2, 2 plus 3 5, 5 plus 5 10, 15, 15 plus 3 18, 18 plus 4 22. So WSFR column total is 220. Whereas WSFR into S, survival rate into WSFR column total is, it comes to 195.4. Sorry, 5. Now GRR and NRR. So formula to calculate GRR is equal to I into summation 50 to 49 WSFR. So I is here 5. So GRR is equal to 5 into 220, that is equal to 1100. So 1100 is per 1000 women. We need to calculate now per woman. So GRR per woman is equal to GRR per 1000 divided by 1000. That is 1100 divided by 1000. That is equal to 1.1. So GRR per woman is 1.1. If the question is asked to calculate just GRR, if they are not asked to calculate NRR and we have calculated only GRR, means the comment based on the GRR is, so here GRR per woman is more than 1, greater than 1, that is 1.1 here. So it indicates, it tells that the population is going to increase. Okay. Now let us calculate NRR. What NRR tells here? NRR also tells the same, whether population is increasing or decreasing. Let us see. So formula to calculate NRR is I into summation 15 to 49 WSFR into survival ratio into S. The total of WSFR column into S column is 195.5. So I is 5 into 195.5. So we get NRR per 1000. We get 977.5. So NRR per woman. So NRR per woman, same. NRR per woman is equal to NRR per 1000 divided by 1000. That is 977.5 divided by 1000 is equal to 0.9775. So approximately, if you round it off, 0.98 we get. So NRR per woman is 0.98 or 9775 or 0.98. Now, so here if the question is asked to calculate only NRR, then the comment will be based on the NRR, that is population is decreasing as NRR is less than 1. But here question is asked to calculate both GRR and NRR. Now what would be the conclusion here? So when we calculate both GRR and NRR, and GRR is more than 1 and NRR is less than 1, in such cases NRR should be considered, because NRR considers the mortality ratio. So it leaves the person who are going to die. So or female birth or female mothers, anybody if may die here, population is going to decrease in the future. So that up to that extent, population will not increase. So population may increase, but it is not up to that mark. So here it is telling that it is less than 1 means no doubt population is going to decrease. If those many persons, those many female mothers or baby dies, the population is going to decrease in future. So here the comment would be, though the GRR per woman is less than 1, NRR per woman is, here GRR is greater than 1, NRR per woman is less than 1, therefore population is decreasing because NRR considers mortality ratio. So when we calculate both GRR and NRR, and GRR is greater than 1 and NRR is less than 1, population is going to decrease. Why we consider NRR? Because it considers the mortality ratio, so which gives us accurate result. Dear students, just now we completed we solved problem on growth rate, that is GRR and NRR, and we learn everything about both concepts GRR and NRR. And before that we learn fertility rate. So fertility rate tells us what is the birth rate in the location per thousand, how many are taking births, and we can compare with help of a TFR, that is what is the birth rate of a different location, and also growth rate by GRR and NRR. Now we reach to the next concept, that is mortality rates. Mortality ratios or mortality rates. So here mortality rates, it studies the death or death pattern, and here deaths we can study in different concepts again, like fertility rates. So first one comes here, crude death rate. Crude death rate, that is called as CDR. So it is just like CBR, crude birth rate. So there we are studying the births irrespective of the gender, their age, and etc. etc. In the same way here, crude death rate, which studies the death rate of entire population in any location. So here it doesn't segregate or separate here population according to their gender or maybe even according to the age group. So here irrespective of age or gender, it considers total death and total population in particular location. So it is I can say it is as same as CBR, and here the formula to calculate CDR. So CDR is equal to number of deaths in the year or during the year divided by average population in the year into 1000. So in short we can write that as D divided by P into 1000. D indicates death, whereas P indicates population into 1000. So next concept is second one, age specific death rate. Okay. So it is as same as ASFR, where we studied fertility rate based on the age, according to the age, different age or different age groups. And here we studied death pattern according to the age, in which age or age group how many persons are dying in different location, or for the same location for different age group how many persons are dying, whether death are more in old age or working age or child age, in which age group deaths are more, that all we can study here. And here when comes to the death, so here age group we cannot divide as we divide the population in calculation of ASFR. So because there only females of childbearing age are considered as giving birth and they are giving birth to the babies, whereas death here it doesn't bother about the age or gender. Irrespective of age, gender, in any age any person may die. Even a newly born baby also may die, even an old age person may die, or even a working person or a 25 to 40 age person or teenage person, any person may die. So here age group may be divided in any pattern as per the requirement of the study. So age may be 0 to 5, 0 to 10 or 0 to 20, 0 to 40, 40 and above, anyway. So here the formula to calculate ASDR is, so ASDR is equal to number of deaths in a specified age group in the year divided by total number of population in that particular age group in the year into 1000. So that we can write in short as dx divided by px into 1000. So dx indicates here deaths in the x age group and px indicates population in that x age group. So these two here, when we calculate these two, we cannot compare with the other locations here by both here. It may be CDR or it may be ASDR. So CDR we can compare the same location for different years. So last year what was the death rate and current year what is the death rate? So we can compare both, but we cannot compare with other location because population pattern may differ from location to location here, and as again it's same in case of what ASDR. So ASDR also cannot be used to compare with other locations. Next comes here to overcome these all and where to compare with other location, that is third concept is standardized death rate. So here standardized death rate, I can say that it is as same as TFR, but calculation is totally different. So here there is no particular fixed age groups. So an age group may be anything. But here instead of calling it as a total death rate, we are calling it as a standardized death rate, because here one particular population is considered and treated as a standard population. So where everything is set normal. Their medical facilities, nutrition, food, everything here they are available, and in those all standard situation, what is the death pattern? So what is the population pattern there? And keeping that into consideration here, we calculate that death rate for given location, and then only we can calculate standardized death rate and we can compare with other locations. So without standard population, we cannot calculate standardized death rate here. So TFR we can calculate for any location irrespective of their population pattern. So just we take age group in the 7 groups of 5 year age width. that is 15 to 19, 19 20 to 24, up to 44 to 49, total 7 age group. But here that is not the case. So one population we keep it as a standard population and we calculate STDR. So here the population to calculate, so here it is calculated for comparison of between two locations. So first location we call it as a location A, and second location as a location B. So for location A, so standardized STDR for location A is equal to summation PA divided by summation P. So P indicates here standard population. So A indicates ASDR of location A. So A into, that is ASDR for particular age group, into the standard population in that particular age group. The total of ASDR and standard population divided by total of just standard population. And when it comes to location B, so we write STDR of location B is equal to summation PB divided by summation P. So here B indicates ASDRs of location B and P standard population. So if we are comparing with another location, location C means summation PC divided by summation P. So just we compare here two locations. So formula is summation PA divided by P for location A, and for location B summation PB divided by summation P. So these are the main three mortality rates which we study here. Apart from these, we have another three mortality rates which are considered as a special here because of their calculation pattern. So let us discuss them one by one. First one here, that after standardized death rate, so first death rate is, so first among them is fourth one, infant mortality rate, that is IMR. So what is the IMR? What is infant? So infant means here these three are special, I said. So here infant mortality rate, which studies the death of babies, and particularly babies who are less than 1 year age. So a baby, if a newborn baby, if it dies before reaching its first birth anniversary, that is first year birthday, so if it dies, that is considered as death of an infant. So we study that particularly here, because if a baby is dying within the year, means the babies are not getting either nutrition food or medical facilities or advanced medical facilities. So to make sure that in our country or in a location, infants are not dying or dying in a less number. So it is necessary to study that how many are dying in infants. So which is studied separately apart from other death rates here. So no doubt in the calculation of CDR and STDR, even ASDR, infant death are taken into account, but they are not studied them separately there. So they are mixed with all the deaths and they are calculated. But here infant death only taken into account separately. So out of total live births, so in a year, how many live births are taken place? And out of those live births, how many died before reaching their first year birth anniversary? So here, remember here, we are studying here infant death. If a baby born dying after dying in the womb of the mother, it is not considered. That is still birth are not taken into account here. The baby should born alive and it should die before reaching its first birthday. So that is considered as what? Infant death. If a baby born dying in the mother womb, it is not taken into account. So here the formula is totally different. It should be remember here properly. So IMR is equal to number of deaths in infants. Number of deaths in infants or among infants in the year divided by total number of live births. Total number of live births in the year into 1000. So remember, in the calculation of CDR and STDR and even ASDR, so total population is taken in denominator part. So total deaths divided by total population in that particular age, or maybe depending on the formula here. But in case of your IMR, infants mortality rate, total live births are taken into consideration. So out of total live births, how many are dying within 1 year? And our next concept is, the fifth concept, neonatal mortality rate, that is NMR. So what is neonatal? Neonatal means a baby which is less than 28 days or 4 weeks. Hasule anta karibadu. So here, if a baby, newborn baby which is born alive, and if it dies before reaching its 4th week or within 4 weeks, if a baby dies, it is considered as neonatal baby death, and it is also studied separately, because if a baby is dying within 28 days, means it indicates that the location has not available with medical advancement or advanced treatments and nutrition foods. Okay, so here the formula NMR is equal to number of deaths among neonatal in the year divided by total number of live birth in the year into 1000. So total number of live deaths among neonatal. So neonatal means what here? Within 28 days. If a baby dies within 28 days. So number of neonatal deaths divided by total number of live births. So out of total live births, how many are dying here? And next important one is, that is the sixth mortality ratio, maternal mortality rate, or MMR. So maternal mortality rate means here, it studies the mothers, death of mothers due to childbirth cause. So IMR considers the death of babies within 1 year, NMR considers the death of babies within 4 weeks or 28 days, whereas MMR, maternal mortality rate, considers here, it takes into account death of mothers. They died, if mother died while giving birth to the baby, or childbirth cause, critical condition, child giving birth given to child, if it is a mother in a critical condition, so if she died because of or due to childbirth cause, then it is studied specially here. That means here it indicates again medical facility. Due to lack of medical facilities, mother may die while giving birth to the babies, or even medicines or nutrition food, or the working condition, or the weather condition, or various factors which may affect, so that mother would die while giving birth to the babies here. So here the formula is MMR. MMR is equal to number of deaths of mothers. So remember here, not all the mothers, only mothers who died at the time of giving birth to the baby. So number of deaths among mothers who died due to childbirth cause. Due to childbirth cause in the year divided by total number of births. Total number of births in the year into 1000. So here remember, here we have not mentioned live births. So in these two cases, IMR and NMR, live births are taken into account and death of babies within 28 days or 1 year. Whereas when we study maternal mortality rate, that is death of mothers due to childbirth cause, even though the child may take birth alive or it may be stillbirth. So here it is considered as total births. It may be stillbirth or maybe live birth. So total number of births in a year divided by, so that is number of mothers who died due to childbirth cause and total number of birth during the year. So these three are separately studied: IMR, NMR and MMR, where live births and births are taken into account. Whereas first three, CDR, ASDR and STDR, where total population and deaths of a different age group is taken into account. So next, learn them by solving the problem. So first let us solve problem on calculation for calculating CDR, ASDR and STDR. Then we will learn these all. So here we have a problem to calculate CDR. So calculate CDR and ASDRs for the following data. So here age group, if you consider here, 4 classes given: 0 to 19, 20 to 39, 40 to 59 and 60 and above. And population, mixed population, both male, female are given here, and deaths also mixed deaths. Now what is the formula to calculate a CDR? So to calculate CDR, CDR is equal to number of deaths during the year divided by average population in the year into 1000 into 1000. So to calculate the CDR, we need to make the total of both the column here. So first 10,000 plus 12, 22,000 plus 11, 33,000 plus 5,000, 38,000, and total of deaths. So 300 plus 800, 1,100 plus 1,200, 2,300 plus 1,500, 3,800. So CDR is equal to 3,800 divided by 38,000 into 1,000. So we get CDR is equal to 3030 will get cancelled. So 3,800 divided by 38, that is 100 per 1,000 individuals. So CDR is 100 per 1,000 individuals. That is, if the population is 1,000 for the location, 100% will die in the year. So it is per 1,000. Next, they are asked to calculate ASDR. So ASDR compared to fertility rate, ASFR, here there is no restriction for particular age group itself. So for the all age group we can calculate here. So ASDR formula, I will write in short. So deaths in the age group X divided by population in the age group X, PX, into 1,000. So don't write in short in exam, write it in full. That is a number of deaths in a specified age group in the year divided by total number of deaths in total population in that particular age group into 1,000. So first ASDR for age group 0 to 19. 0 to 19 we calculate here. So dx, death in the first age group is 300 divided by population in first age group is 10,000 into 1,000. So we get 3 zeros get cancelled. So 300 divided by 10 is equal to 30. So first ASDR here. So ASDR is 30. Then second one, ASDR for age group 20 to 39. So number of deaths is 800. 800 divided by 12,000 into 1,000 is equal to. So 800 divided by 12, we get 66.66666. So that will make as 66.67. So for the third population, 1200 deaths divided by 11,000. So 1200 divided by 11,000 into 1,000 is equal to 109.090909 we get. So that is 109.09. And for last age group, that is 60 and above, ASDR is 1500 divided by 5000 into 1000 is equal to. So zeros will get cancelled. So 1500 divided by 5, we get 300. So in the last age group, death rate is more. So that is 300. So this is how we calculate CDR and ASDR when a population and deaths for different age groups are given. Now next we calculate a problem on standardized death rate where directly death rate per thousand is given. That is the ASDRs are given and a population standard population is given. Dear students, here is a problem on calculation of STDR, and this kind of problem may come for 5 marks in the annual exam. So here they made a task easy here. So instead of giving the population and deaths, they have given deaths per thousand. So deaths per thousand is nothing but here ASDR, age specific fertility rate for particular ages. They are given ASDR directly. So ASDR for town 18, 6, 8, 10 and 18, and ASDR for town B are 12, 4, 8, 9 and 90. And as I said, to calculate STDR we need standard population. So standard population is given here. Now we have to calculate both STDR for both the location and compare both and write a comment on health condition of the location, that is which town is healthier here. So to calculate STDR, first make a separate table here. So age group, that is below 10, 10 to 20, 20 to 30, sorry 20 to 50, 50 to 70 and 70 and above. And town A is ASDR, we can write it as a A. So that is 18, 6, 8, 10 and 80. And standard population as P. P is 15,000, 18,000, 22,000, 12,000 and 8,000. Now calculate P into A. That is for calculation of standard death rate. So that is STDR for location A is equal to summation PA divided by summation P. So we have to calculate PA column now. So 18 into 15,000, we get 2,70,000, and next 6 into 18,000, that is 1,08,000, and next 8 into 22,000, we get 1,76,000, and 10 into 12,000, 1,20,000, and last 80 into 8,000, 6,40,000. So make the total of the columns here, so that we need to make total of both P column and PA column. So P column total comes to 75,000 and PA column total, that is that comes to 13,14,000. So 13,14,000. So STDR of A is summation PA divided by summation P. So summation PA is 13,14,000 divided by summation of P is 75,000. 75,000. So STDR of location A is equal to 13,14,000 divided by 75,000 is equal to 17.52. Now let us calculate STDR for location B. So here town B, age group below 10, so 10 to 20, 20 to 50, 50 to 70, 70 and up. Next B, that is the ASDRs of town B, 12, 4, 8, 9 and 90, and B, that is standard population given here, 15,000, 18,000, 22,000, 12,000 and 8,000. So next we need to calculate P into B, that is so STDR of location B is equal to summation PB divided by summation P here. So that means we have to calculate P into B column. So 12 into 15,000. So 12 into 50,000 is 1,80,000. Next 4 into 18,000. So 4 into 18,000 is 72,000. Then 8 into 22,000. So 8 into 22,000 is 1,76,000. Next 9 into 12,000. So that is 1,08,000. And last 90 into 8,000. 7,20,000. So already we calculate total of P column, that is 75,000, and total of PB column. So total of PB column is 12,56,000. 12,56,000. Now calculate STDR of B. Summation PB is 12,56,000 divided by summation P is 75,000. So STDR of location B is 12,56,000 divided by 75,000 is 16.7466. So approximately is equal to 16.75. 16.75. Now compare both STDRs here. STDR of location A is 17.52, whereas STDR of location B is 16.75. So which one is less here? Obviously town B's STDR is less. So their comment we have to write STDR of B is less than STDR of location A. Therefore town B is healthier. So which location's STDR is less, that location is healthier. Okay, and when it comes to fertility, TFR, which location TFR is more, that location is more fertile. Okay, so fertility, higher the fertile, less the STDR, healthier.